Hi students, and welcome to your next math lesson. Today we're looking at the final lesson for Chapter 9, Lesson 13, Subtract with Renaming. Students will be able to use fraction equivalence to subtract with renaming. So what this means is kind of similar to the idea of when you subtract whole numbers and you have to borrow or regroup. When you're subtracting with fractions or mixed numbers, you might have to do that. You might have to borrow or regroup, and we just call that renaming, because we are trading in one thing for the same amount of space, but just rewritten differently. So our first problem says 2 minus 1 1/3. 2 wholes minus 1 whole and 1/3. I'm going to show you this using my virtual manipulatives, my fraction strips. I'm going to start off by building my 2 wholes. 1 whole, 2 wholes. Okay, remember, we are starting with 2 wholes. Now I need to take away 1 whole and 1/3. Well, when I look at this, I see I can take away a whole, but I don't see anything in thirds. So because my denominator is a 3/3, I want to trade in or rename one of these wholes for thirds. So let's see how many thirds it takes to equal 1 whole. Hopefully you already know the answer to that. It takes 3/3 to equal 1 whole. I've traded in or renamed. Notice I have the same amount of space as 2 wholes. Here are my 2 wholes. I renamed it using the denominator from my mixed number. So I still have 2 wholes right here, just written differently. Now remember, my problem says with those 2 wholes, I need to subtract 1 whole and then 1/3. And now I can see that I can do that. I want to take away 1/3 and 1 whole. I took away 1/3 and 1 whole. So what am I left with? Well, I don't have any wholes left. I only have 2 of these third pieces. So my difference, because I'm subtracting, is 2/3. Now, how can I do that without the fraction strips? I'm going to show you the steps. First off, just like we have been, I'm going to line up my problem vertically. Whenever we have fractions or mixed numbers that have different denominators, we've been lining them up vertically. So again, I have 2 wholes, but I need to take away a whole and a fraction. 2 is not currently written as a fraction or mixed number, and I want it to be. So here's where things can get a little tricky. If we think back to what we did originally, remember we had 2 wholes, but we traded one of those wholes in for 3/3. That's what I need to show here. So I need to rewrite or rename my 2. And instead of it showing 2 wholes, I showed 1 whole and 3/3. Remember? 1 whole and 3/3 was the same amount of space. Why am I picking thirds? Because my denominator in my problem was thirds. Now, just like we did when we subtracted mixed numbers the other day, I have like fractions because they have the same denominator. I can subtract them. 3/3 minus 1/3 gives me 2/3. And when I subtract my whole numbers, 1 whole minus 1 whole gives me 0 wholes. So I get 2/3 as my difference. And when I show that to you one more time, I'm subtracting 1/3 and 1 whole, and I'm left with 2/3. All right, now I want to show you an example of when we have two mixed numbers. That example had a whole number and a mixed number. Our next problem is 4 1/4 minus 2 3/4. All right, so for this example, I see that I'm subtracting two mixed numbers. I notice I have a common denominator. That's always helpful. But when I look at my numerators, I have 1 minus 3. Well, a lot of people say you can't do 1 minus 3. You can, you just get a negative. All right, so let's rename these mixed numbers so that we can take 1 minus 3 without getting a negative in that fraction. I'm going to model this for you. So let's start by building 4 1/4. I need 4 wholes, and then I need 1/4. Okay, so looking back at our problem, 4 wholes and 1/4. 4 wholes and 1/4. And what am I taking away? 2 wholes and 3/4. Now, when you look here, you might say, I don't have 3/4 to take away. We do, they're just hidden. They are hidden inside one of these holes. So we need to rename one of these whole pieces into fourths. So think of how many fourths it will take to equal a whole. Yeah, 4/4 are going to equal 1 whole. So let's trade out 1 whole for 4/4. And you can see that 4/4 is the same amount of space as that 1 whole. Same amount of space, I just renamed it. All right, so now when I look back at my subtraction, remember I'm taking away 2 wholes and 3/4. I haven't taken anything away yet. I've only traded in or renamed. So let's take away those 3/4. 1, 2, 3. I took away 3/4. And now I need to take away 2 wholes. 1 whole, 2 wholes. And what am I left with? 1 whole and 2/4. 1 whole and 2/4. Now, I'm hoping that a lot of you are looking at that 2/4 thinking that can be simplified into a half. And you're right, it can be. 1 2/4 is the same thing as a half. So my final answer in simplest form is 1 1/2. So let's see how we do this without the fraction tiles. I'm going to start by lining up my problem vertically. I notice I already have a common denominator. That makes things a lot easier. It gets even more complicated when we have to find the common denominator. But then I notice if I do 1/4 minus 3/4, I have to borrow. Okay, so let's do that borrowing. Going back to my fraction strips, let me put my original amount up here. We had 4 1/4. So remember, when we tried to take away 3/4, we had to do some borrowing and trading. So what did we do? We took one of the wholes and replaced it with 4/4. So let's look at that on paper. I took away one of my wholes, which left me with 3 wholes. And I replaced it with 4/4. Now watch how I do this on paper. I took away 1 whole, which left me with 3. And then I replaced that whole with 4/4 right here. So you might be wondering why I put a plus 4/4. Well, we're not adding an entire extra 4/4 to our original problem. This right here is the trade. Think of it. 3 and 4/4 is like 3 plus another whole, which gives me that 4. So how many fourths do we have altogether? 1, 2, 3, 4, 5. So really, we have 5 fourths. 3 and 5 fourths. I know that part is a little confusing. So that when I go to subtract, I'm not subtracting 1/4 minus 3/4. I'm not subtracting 4/4 minus 3/4. I'm subtracting all of my fourths after my trade. 5/4 minus the 3/4. Remember when I did this the first time, I took away from all 5 of these. And if it helps you to put them down here together, go for it. And I took away 3. And I was left with 5/4 minus 3/4, 2/4. And now let's take away our 2 wholes. Don't forget to do your wholes. And we're left with 1 and 2/4, because 3 minus 2 equals 1. And then, of course, remember we simplified that to 1/2. I suggest in the beginning using the fraction tiles if this is confusing, because this can be really confusing for a lot of students. Okay, that's why it's the last lesson in the chapter. Again, if you have to make common denominators, it gets even more complicated. All right. I will see you next time. Enjoy. Goodbye.